How do you solve this problem? Pause this video, give it a try. I'll be solving this in a very simple way, but let's try to understand this. For every sine and the cos, we have their ranges from -1 less than, let's say I have this as sine x, and this is also less than or equals 1. The value must not greater than, must not above, between the range of -1 and 1. But since 2 that we have here is greater than 1, showing that there is no real solution. Now, how do we solve this? Very simple. If there is no real solution, it means there is a possible we have a complex solution. But before we watch further, subscribe to this channel, turn on the notification bell as you are able to get new content anytime I upload a new video. Let's solve this step by step. So since we are looking for the complex solutions, what we do first is we are going to recall from the identity of sine. Anytime we have sine of a function like this, we are going to consider it as, for every sine x, so this equals to exponential of ix minus exponential minus ix divided by 2. This is what we have. And if everything equals to 2, we are going to have exponential of ix minus exponential minus ix equals 2i multiplied by 2. That gives us 4i. And with this, I need to get the value of x. What I will do now is, I'm going to let, if I let exponential of ix equals another thing, if I let it to be equals t, then we are going to replace it as t minus t raised to the power minus 1 equals 4i. So for t raised to the power minus 1, this equals 1 over t. Then we are going to replace this as t minus 1 over t equals 4i. By multiplying through by t, this becomes t squared minus 1 equals 4ti. And let's take this 4ti to this left hand side. We have t squared minus 4ti minus 1 equals 0. This is a quadratic equation that we are going to solve. So let's solve this. The variable we are looking for is t, and from the quadratic equation, a is 1, b is minus 4i, and c equals minus 1. Using t equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Then we are going to have t equals 4i plus or minus square root of 16i squared. And we have minus 4 multiplied by a is 1 and c is minus 1, all divided by 2 into bracket of 1. So if this is cleared, we are going to consider I square is minus 1. Okay, so the I square is minus 1. Then we have t equals 4i plus or minus square root of minus 16 plus 4, all divided by 2. So for this we have t equals 4i plus or minus square root of minus 12 and divided by 2. But square root of minus 12 gives complex, and that gives us 2i square root of 3. So we have t equals 4i plus or minus 2i square root of 3 and all divided by 2. For this can be reduced to t equals 2i plus or minus I square root of 3 divided by 2. Or we can simply call this I, we factor out, and this is 2 plus or minus root 3. 2 plus or minus root 3. So this 2 has been reduced, so we don't need this 2 again. So we just rewrite it in this form. So we got t as I bracket 2 plus or minus root 3 it doesn't end there. Let's try to recall where we let exponential of ix equals t. Okay, and with this only, suppose I want to get x here, I'm going to introduce ln to both sides. So by introducing ln ix, this equals ln of t, this cancelled, and we have ix equals ln of t. So since I need x, I have to divide both sides by I, divide both sides by I. So this cancel this, and we have x equals ln of t divided by I. So this is what we have for x. Okay, so this is one way of getting this. And if we cannot apply this, we can firstly substitute exponential of ix directly here as t. Then we later take the logarithm of both sides. Okay, so and again we have I. Suppose I let I here equals exponential of I pi divided by 2. So when we substitute these two back to what we have above, we are going to have the final result of this equation as we have x equals pi over 2 minus ln of 2 plus or minus square root of 3. So this is what we have. But to make it general, we are going to add plus 2 pi of k, and where this k is a member of an integer. Thanks for watching. See you in the next video. Never stop learning. Bye bye.